Okay, welcome back to COSC 2325. This is chapter 4. And in this chapter, we're going to cover data, transfers, addressing, and arithmetic. So this chapter is all about how we transfer data between a memory location to a register to a memory location, addressing, and how we do arithmetic. So the first thing that we need to cover and review is the different registers that we have available. So there's 4 32-bit data registers that are used for arithmetic, logical, and other operations. So there's 4 of these. And if you remember, these are the EAX, EBX, ECX, and the EDX. So if we want to use the complete 32 bits available, we would reference one of these, which are the ones that we have been using. And I started a little bit of chapter 4 at the end of the chapter 3 video because I showed you how if I tried to put 8 bits into a 32-bit register, it would not let me, it would give me an error. So that is one of the rules when putting data into a register, is that you need to make sure it's the same size. So if you have a variable that's 32 bits, then you can put it into a 32-bit register into one of these. But let's say that you don't. Then if we remember back to chapter, I think 1 or 2, we talked about these other registers, names that we have available that reference part of those 32 bits. So if we say AX will actually allow us to use 16 bits. So that will be a 16 bits of the register, and the register is still using the EAX register, but it's just using 16 bits. And then BX is using 16 bits, CX 16 bits, DX 16 bits. Then we can actually take these 16 bits, so right here, and we can use half of them. So that would be 8 bits. So it would be, if we define a variable to be a byte, we could either put it in the lower half of these 16 bits or the upper half of the 16 bits. So we can use EAX and all of these. If we define a variable that's a double word, we could put that into, right? This whole thing. Bytes we can put into these that end in L or H for the upper or lower half of our 16-bit register. Or if we have something that's 16 bits word size, then we could use these names. So what I'm going to do is I'm actually going to talk about this chapter using a lot of examples. And what you can do from home is you can pause the video, type in the examples, run it, and test it. So I don't want you just to watch the video. I want you to actually type this in. It's what we do in class. We type in the programs, everybody types them in, everybody runs them. Everybody's looking at the registers, watching the variables. So it's really the only way that you're going to learn how to do this is if you practice. And this is part of that practice, not just the lab assignments. So I'm going to go ahead and open Visual Studio. I'm going to create a new project. Empty project. And I'll just call it project 1 because I think I had a project 1, but I deleted it. Your projects that you save in your directory, whatever directory you're using, cannot You you can't have more than one project with the same name. It'll let you know. And then remember, when you're in here, you're going to right click on the project name and you're going to first build your dependencies. Check off MASM. And then you want to make sure that it's an 486 processor. And that's it. So you've got everything that you need. And then for you at home, you're going to create a new project. I'm going to go ahead and, excuse me, not a new project, a new item. I'm going to go ahead and add an existing item so that we can make this video go faster than you watching me here type everything. But make sure that at home you are typing it. So we're going to look at the first example here. Okay, so in this example, we're showing how both operands must be the same size. Both operands cannot be memory operands. And this is a review, we looked at this last time. The instruction pointer register IP, EIP, or RIP cannot be a destination operand. And we're going to talk about the instruction pointers later. Not right now, but for now we know we cannot use those. So here we've defined a data label. So this is like a variable of type byte. And this byte is holding, so remember byte is 8 bits. And then this should say 1 byte, not 2. Okay, so I was tired when I did this. So 16 bits is 2 bytes, because remember 8 bits is 1 byte. And then here we have 4 bytes. So 1 byte is just the variable name. It's just a label. And it's of size byte. And it holds the hexadecimal value of 78. Word holds the hexadecimal value of 1, 2, 3, 4, and double word holds 1, 2, 3, 4, 5, 6, 7, 8 hexadecimal. So in this example, the first thing that we do is we move 0 to EAX. So let's watch this. So I'm going to go ahead and put my breakpoint here. And my 0 is just going to clear out my register. And the reason I want to clear out my register is, notice EAX has this value in it, this hexadecimal value in it. And I'm about to put something in the lower half. So I'm just going to use 8 bits. And so if I just used 8 bits, I'm just going to use 7, I'm just going to replace this 75 here. And I don't want all this there, because then my number is invalid. Like, it's not what I meant to put in there. So it's like I want to clear out my register and then move something in there. So the other thing I want to look at, if you go to debug window, let's go ahead and watch our variables. And we're not changing our variables right now, but we can also watch what's inside our variables. So 1 byte has right here. So we have 1 byte, and it has the hexadecimal value of 78. And one byte. Let's do one word. So one word has the value of 4,660. And we'll do double word. You can take this and move it. And we're not changing these values. So these values are being changed to decimal here. So we see the decimal value for these. We're not changing these variables, but if we were, then we could see how they changed here. But all that we're changing are the registers. So let's go ahead and debug and step over that line. So now we've zeroed out EAX. That's what that did. Debug, step over. So the lower half of EAX, the last 8 bits, have been replaced by 78. So here's 78. Remember, we have 1, 2, 3, 4. So these here, this is AH and this is AL. And then like from here on, we have AX. So now AH is going to be replaced by also 1 byte. So let's run that. Debug, step over. So now we have 78, 78. So this is AH right here. This is AL right here. Now in AX, we're going to put one word. Now one word is only 16 bits. And it has this number. So what do you guys think? Or do you think it's going to go here? Or do you think it's going to go here at the end? Let's find out. So that AX is just the 16 bits on the lower half of the register. And then what we can do is I can stop it and we could move into EAX. We could move one double word. So that's this here. So one double word would then replace everything on my register. I'm gonna run it. Debug, step over. So 0, step over 78 on the AL. This is AL right here. Debug, step over 88. AH gives us access to here. Debug, step over. AX gives us access to these 16 bits. And debug, step over. Here we then move this whole number into the entire register. And then we're done. Okay, so just a little bit of looking into how we use these different registers and the different sizes, and they have to match. So if I try to here, if I try to do 1 byte, so 1 byte is 8 bits. This register is 32 bits. It's not gonna allow me to run it. It's gonna give me an error. Let's see what the error says. So the error says the instruction operands must be the same size. So make sure you read the errors. Don't let all this text scare you away. Instruction operands must be the same size. So there you go. Pretty easy. It tells you what the error is. If I double click on the error, it actually gives me the exact spot. So that's nice. right? You can tell which one it is that has the invalid value. Okay, so I'm going to put this back to Word, and then I'm going to go ahead and save this. And then I'm going to open a different go ahead and remove this example, and I'm going to add a new example. Okay, in this example, we're using an instruction called move CX, and move CX stands for move zero extend. So what it does is it copies, let's say that you're copying a byte into a EAX. So you're copying 8 bits into 32 bits. It allows you to do that. It allows you to take smaller and copy it into bigger, and then it zeroes out everything else for you. So it zeroes out all the bits that you're not using. So for example, if you're copying 6, zero extends the value to 16 or 32 bits. Then we have something called move SX, which is move with signed extend, and it copies the contents of a source operand into a destination operand, and sign extends the value. So this is for signed numbers, this is for unsigned. So here we have an example, and we're going to run this just to make sure that it runs okay. And everything ran fine. There are no errors. So here we have a signed word that holds a -10. Now in hexadecimal, -10 is FFF6. And remember that word is 16 bits. And then S means that we're putting something that's negative into this register. The other thing to remember too is that we don't have to use S word. We could just use word, but then it doesn't automatically put a sign for us. So, and we want to make sure that we're using the right directive for the data. Then here word, holds the variable to word holds 0AA1H, and this is also 16 bits. And this variable 3 is 8 bits long. And it holds the binary number 1100, and this binary number is C, the letter C in hex. Okay. And the reason I put the hex value here is because what you're going to see in the registers is the hex value. So I just want you to know what to expect in the register. Okay, for now, I just wanted, I don't want to do this yet. I don't want to talk about the move SX, the signed extent. I just want to work with the move the zero extend. So I'm going to put my break here, and I'm going to run it. So EAX right now has a bunch of, has a value in it, hex number. Step over. var1 is -10. And like we said, -10 is FFF6. And we place it here and we're using a size word, so that means we're using 16 bits. Everything else got 0 padded. So if we hadn't done that, if we hadn't used move CX, we would have gotten an error right here and not been able to run it. And then we're going to debug, step over, because remember, these are 32-bit registers. So we're trying to put 16 bits into 32, 16 bits into 32, and 8 into 32. So EBX now has AA1, so that's the hexadecimal, 0AA1. Debug, step over. And ECX gets assigned the letter C. It's 1100B, so it's binary, but that converts into in hexadecimal as C. So ECX has a C in it. It's just 1 byte or 8 bits. Okay, so I'm going to take my breakpoint out, stop my debugging, and this time I want to see what goes on here. So I'm going to go ahead and comment these out. So an operand is sign extended by taking the smaller operand's highest bit and repeating or replicating the bit throughout the extended bits in the destination operand. So it takes the highest bit. Remember, the highest bit is going to be on, if you're looking at the number on the computer, it's going to be on the left side. The highest bit, the lowest bit's going to be on the right-hand side. So it takes the highest bit and it just repeats it and pads the entire register with that. So if your highest bit is an F, then it'll be all Fs. So in this example, var1 is this one here, and the highest bit is an F, so it will be padded with all Fs. Just repeats all Fs. So let's put a break here and let's take a look at EAX. So EAX starts with this number. And then when you run it, it's F6, and then all the other bits get padded with that F. So we extend with the highest bit, or replicate the highest bit. So make sure that you run these and test them, play around with them so you can see how they work. Okay, let me go ahead and remove this one. And then I'm going to add. Now, I don't want to give you these files because in the class, we actually type all these in. So I want you to do the same thing. Desktop. All right, so here we're using a mnemonic, an instruction called exchange. And what exchange does, it exchanges data. So the exchange data mnemonic instruction exchanges the contents of 2 operands. It's useful for array sorting. Anytime we sort arrays, we have to switch like element 0 with element 1 if element 0 is bigger than element 1. You can exchange values in memory and registers only. So we can't exchange memory to memory, just like we can't, and when we say memory to memory, we mean a variable. So your 2 operands cannot be variables, just like with move, two operands cannot be variables. Move Z, the operands can't be variables, etc. So you can never go from variable to variable. Also, and I don't have it here, you can't switch, like you can't say EAX and put a 5 here. So you can't put a constant. I'll put constant. So some kind of literal constant. I'll put literal. So I can't put a 5 right there. Okay, so here is a variable called 1 and one called 2. They're both double word variables. One holds a J, one holds an A. These are 32 bits or 4 bytes. So remember, 1 byte is 8 bits. So the first thing that we do is we move the letter A into EAX. Then we exchange A and J. So we exchange, yeah, A and J. So in EAX, we move the J, and in 1, we move the A. So let's take a look at this. In this one, we're going to have to look at the variables also to watch the variables. So we'll add an add watch for the variables. Okay. So here are my registers. And then my watch windows down here. You see these tabs. I'm down here. Got registers and watch. And if you have old variables that you set to watch, I'm going to close this other window here on the right because I'm not using it. You can right click and clear all, or you can just delete one if you just need to delete one. So I'm going to go ahead and copy 1 and move it here. And I'm going to copy 2 and move it here. So J in hexadecimal is 74. And A in hexadecimal is 65. I'll put that there. So 74 and 65. And if you go look at the ASCII table, you'll see that capital A is 65 and J is 74. I always memorize capital A because then it will get me, to the next letters. All right, so now we're gonna look at the registers. Let me switch back to the registers. So in my registers, I have, right now I have just a random value that was grabbed from memory, and we're gonna debug and step over. Did I make a change? Oh yeah, I made a change. So because I typed 74 and 65, it said no, can't do that. Okay, let me try it again. All right, so I'm gonna go to my registers and then debug, step over. So now EAX has 2, which is A, which is 65. EA does not have 65H. See here, debug, step over. And then EAX got put into, oh, we exchanged. Okay, so A was put into EAX, and then we exchanged EAX and 1. So one, so here's one thing with exchange. So when EAX gets put into one, so EAX had this value here. So apparently what it puts is, let's go back over here. It was 41. So I put a 41 there. And then, so two, let me just run this again. I can't remember. Debug, oh, run. Okay, debug step over. All right, so two gets moved to EAX and EAX has 41. So EAX has 41. And then debug step over, that 41 gets put into one. And so one used to have a J, but now one is going to have an A. And it does, which is 65. And so these values, I was thinking wrong. The 65 and the 74 are your decimal values, not your hex values. These are your hex values. So 41 and 4A. So 4A is the J. So I'll put an H here. And then in decimal, this was, I think, 74. I'll put a D for decimal, and this is 65 decimal. Yes, so 74 decimal and 65 decimal, and then these are the hex values for these letters. So when these two get switched, what is important to know is that, so EAX had a EAX had one has four, it's confusing, 4AH, EAX has 41H, it has the A, and then that A gets put into one, so one has a 65 now, one used to have a J, and then our EAX has a J and it used to have the A. So the EAX and the one got changed. The variable and this register got exchanged. Okay, definitely run that one. And let's remove this one and add stop. Add item, existing item. Okay. The last example is last example is talking about direct offset. And direct offset, I think I've talked about this a little bit. So whenever you define a string like this, you define your string and you put it into 1 byte. So remember that 1 byte is equals 8 bits. And so what 1 byte can hold is just 1 character. It can only hold 1 character, that's it. And so what happens here is that first name, this variable name here, holds just the letter A. That's it. If we want to get to the letter B, all we have to do is add 1 to first name. We're going to add 1 because this is 1 byte. Each one of these is in 1 byte. So first name is here. First name plus 1 would be the letter B. First name plus 2 would be the letter C. First name plus 4 would be the letter D, so on and so forth. So this is offsetting, and this is exactly how it happens when you work with the high-level languages and arrays. So when you have an array in a high-level language, you have those brackets where you put a 0 to grab, it's an index 0, to get the first element, or you put a 1 to get the second element. Well, this is exactly what it's doing. When you put a 0, it means that the name of the array, you are at the first one. That's why we do 0. We're adding 0. There's nowhere else to go. Then to get to the next, we're going 8 bits or 1 more byte, so we're just going to add 1. Here would add 2, etc. So in this example, we clear out 2 registers. We put 0 into EAX, we put 0 into EBX. We're moving first name into AL. Remember, AL is the lower half of your EAX, of your AX register. Okay, so AX is 16 bits, and half of it is 8 bits. That's AL, and AH is the other half. And so when you put first name into AL, what you're really putting here is just putting the character A into AL. That's it. You're not putting anything else. Then here, you're moving first name plus 1, so character B. So moving better, I like that, sounds better. Moving A into A1. Moving B into BL. And then we're done. So let's watch this. And we're gonna watch the registers only. Actually we could look at first name so we could see that it really just holds the character A. So let's look at that also. Gonna add a break, we're gonna run it. And then we're gonna go to watch window. We're gonna clear these by right-clicking, clear all. Or if I just wanted to delete one, I could delete the watch. But I want to clear all of them. And then I'm gonna move just first name over, my only variable. There we go. So we're watching variable called first name, and it holds the letter A. See right here, just holds the letter A. That's it. It's just 1 byte. The 65 is the decimal value. Remember, decimals are our number system. It's a 10 base system. So 1, 2, 3, 4, 5, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's the decimal system. All right, now we're gonna look at our registers. We're gonna be working with EAX and EBX. EAX and EBX has some random value. When we step over, EAX gets cleared, and debug, step over, EBX gets cleared. Now we're putting first name into AL. So remember, AL is 8 bits. So you can do that. You can put 8 bits. into AL because AL is 8 bits. So first name is 8 bits. That's it. 1 byte. So we're moving just the A into AL. And we looked at this earlier. A in hexadecimal is 41. So A, moving A into AL hex, I'll just do 41 hex. And then if A is 41, then B has to be, step over. Oh, I can't type at this. Let's just ignore it. I think it, no, it doesn't. Well, maybe it does. Doesn't like it when I type these things here, so let me just start over. I'm sorry. Okay, so clear my registers, step over, step over, step over. So this is where we were. First name got assigned to AL, which is the lower half of my AX register, which is only 16 bits. Now BL is going to be right here. This 0 here and the 0 here will get replaced with first name plus 1. Oh, sorry, BL, not, I don't know what I was thinking. So BL is this register over here on this side, so it gets replaced with the 42. So here, if I would have done AH, then it would have done what I was thinking in my head. So BL is this register right here. So it's the lower 8 bits of EBX. So that's 42 hexadecimal. Now notice these square brackets here. Those square brackets are not required. You do not have to put those there. They're just there to really make it clear that we're offsetting. The square brackets are also how we always work with arrays when we do it with high-level languages. So you can remember that from working with high-level languages like C++ and Java. Okay, so here we're just showing how we access each value, whether it's a character, an integer, whatever, in an array. And so when we do an array, this is going to be the only way that we can do it. And of course, when we learn how to do loops, we'll be able to loop through each one of these, through the A, through the B, through the C, by incrementing this counter right here, which is what we do in the high-level languages. It's done for us. We don't have to actually do it. Unless we work with C++, we can actually, it allows us to do that. Now, the one thing to remember with this is that assembly gives us all the power. And just like in C programming and just like in C++, there's no index bounds checking. And what that means is that this is element 1, index 1, 2, 3, 4, 5, 6. So if I do 6 here, I get a G. But if I put a 7 here, it's not going to give me an error. It doesn't know that there's not a letter after the G. And it just keeps going. And that's a problem because that would cause an error at some point. Especially if you write to first name plus 7, if you change that value and first name plus 7 has an instruction, then that's going to crash your program or do some weird things to your program. So it does not do bounds checking. So you have to make sure that you're using, that you're not going beyond the number of bytes that you have in your array. Okay, so this section, I'm going to stop this video, but I just want to show you, if you have not read your book, make sure that you read all of section 4.1. So this is all of section 4.1. I did not go over 4.1.6. I'll do that later. But all this right here is 4.1, starting with a little bit that we talked about in the previous video at the end of chapter 3. But it's so important that you understand this. So if you have to read it a couple of times, type in the programs, it really is going to take a lot of effort. But if you're comfortable with this right now, then it's going to make the class a lot easier. Okay. And then this is what we have to look forward to. We're going to learn some more, all these in blue are going to be some more mnemonics, some more instruction mnemonics that we get to use in our programs. So in here, we're actually going to get to do loops. So we get to do everything except for conditional statements. So no conditional statements in chapter 4. We'll do procedures in chapter 5 and then conditionals in chapter 6. So, okay. All right, practice away and email me if you have any questions.